Okay. This paper was given a few weeks back, but we didn't have a proper support to go ahead with the discussion. Now, from this week onwards, we are going to have a paper every week, and at the same time, we are going to have a discussion every week. Right. Now, in this paper, there are altogether two problems. I first start with trig. So, part B. This problem number 2, part B. In fact, I have just finished the discussion for the single medium class. So I'll leave this like that, then I'll explain you how to obtain that. Now, in this case, in part B, we need to write the formula for tan A plus B. We need to write the formula for tan A plus B. So that's it. Tan A plus tan B over 1 minus tan A tan B. Very rarely you are given these type of problems because they allow you to score some points. Usually, on the average, there are about 800 zeros for combined math. So it will, it will look the setters of the papers bad. It seems like they have set a paper so that nobody can score. At least 800 people scored 0. So that's not good on them. Therefore, they sometimes give you easy parts to score. But in the other subjects, they have MCQs. Therefore, they can score some points, even though they have no idea what's going on. They can score some points. But in math, it's not like that. Even in maths and combined maths, in both subjects, they get zeros. Therefore, they sometimes give these type of questions. Now we have to find tan to theta. So like in the theory, you choose theta for both A and B like this. Then substitute theta for A and B, you will end up with this. Tan squared is, tan times tan is tan squared. Now, we need to obtain another formula for tan 3 theta. So to obtain 3 theta, again, you have to use the same formula. So choose 2 theta and theta for A and B respectively. So you get tan 2 theta plus tan theta over 1 minus tan 2 theta tan theta. Right above this, you have a formula for tan 2 theta. You substitute that. Now, once you hit this point, you have to be a little careful in simplifying this. Some people try to, some people try to do is that they simply take the common denominators of both upstairs and downstairs. It looks a little messy. But if you want to arrive at the answer quicker, so you have to multiply each and every term by 1 minus tan squared. Because in both downstairs you have, there are altogether 4 terms. So in the downstairs you have 1 minus tan squared. So to get rid of that, you multiply each and every term by 1 minus tan squared theta. So you will end up with 2 tan theta. So you can get rid of this. And at the same time, you can multiply tan theta by 1 minus tan squared theta. You can multiply this by 1 minus tan squared theta. And when you multiply this guy by 1 minus tan squared theta, this will go away. It leaves you with 2 tan squared theta here. Now, you can gather similar terms. 2 tan theta plus tan theta will give you 3 tan theta plus times minus. So negative tan cube theta. It's up there. And in the downstairs, you have like similar terms. So 1 minus 3 tan squared theta. So you get what you need. After that, you have to show that tan 20 is a root of a certain equation. In fact, this equation. So this is how you have to do it. Your approach should be something like this. Say, for example, you take some value, say 5 cube. right, is in fact 125 minus 21 times 5. That will give you 105. So to 125 minus 105 will give you 20. So if you subtract another 20, it will be 0. Now, if you replace 5 by x, you will end up with this. Now, you can say that what you can claim is that 5 is a root of this equation because you just replaced 5 by x. So on the other hand, if you substitute 5 there for x, you will end up with the correct statement. So that equation is correct. If you substitute 5, you get 0. Therefore, on the other hand, if you have an equation like that, if you obtain it in this fashion, you can see that 5 is a root of this equation. So we are exactly going to play the same trick here. So you have this formula at your hand, right? You want to obtain a cubic equation, something like this. So, and at the same time, you want to show that tan 20 is a root of this equation. So come up with tan 20. Using this, you come up with tan 20. Luckily, when you multiply 20 by 3, you get 60. So if you substitute 20 there, right? So 20 degrees, you will end up with this. Take theta as 20. So you will end up with this. Here, 3 times 20 is 60. Now, the fortunate, the good thing is that tan 60 is square root 3. That is something you know. Like if you had something like, say, 24, then tan 72 is something unknown. But with 20, what you get is tan 60, which is completely known value. Now you just cross multiply. So if you cross multiply, you get this. You have to come up with an equation now. You will end up with this. Now bring everything to one side. Usually, the highest power term. So, you take those terms to one side so that the term carrying the highest power has the positive coefficient. So this is negative tan cube. So if you bring it to this side, it is tan cube 20. Now you write it as it is. Bring this to the left-hand side. It appears as minus 3 tan 20 plus square root 3. Now what happens is that now it is an equation containing tan 20. Now exactly do what we did here. You have some correct statement, replace 5 by x. Similarly, replace tan 20 by x. So you will end up with this x cube minus 3 square root 3 x squared minus 3x plus square root 3. Now what you can claim is that once you have this, you replace tan 20 by x and claim that tan 20 is the root of that. This is something we know for the next part. So don't worry about that at this point. So we are done with that. Now we'll go for the next problem, which is part C of problem number 2. That's relatively easier. I gave you those questions as practice questions, but now you have a better hang of those things. You have a better exposure and better experience in those things now. But we'll try to see how we can obtain them. Now, cosine 3 theta is this. You want to prove this. You can do it in either way. If you want to start with the right-hand side, you can pull out, okay, this is what you have. You have to replace cos 2 theta by this because you need everything in cos theta. Why? These are the formulas we need to prove these results. Cosine 3 theta is 4 cos cube theta minus 3 cos theta. You can express cosine 3 theta totally in terms of cos theta. When it comes to cos theta, 2 theta, again, the case is the same. You can write it in terms of cos theta only, like this. If you want, there's another formula for cos 2 theta. There are two more formulas. But if you start with this, you can completely express cos 2 theta in terms of cosine. Now, sine 2a is this, that is, you already know, 1 minus cosine squared is sine squared. Now, For this, for this problem, you need these two. Now you start with the right-hand side. Now you need to write, now to prove, to obtain cos 3 theta, you have to write everything in terms of cos theta. So replace this guy by 2 cosine square theta minus 1. You will eliminate the bracket. 2 times 1 is minus 2, minus 1, minus 3. Now eliminate the bracket. You get 4 cosine cube theta minus 3 cos theta, which is exactly cos 3 theta. That is the first problem. In the second one, tan A plus cot A is 2 cosec 2A. So you have to, it is like reverse engineering, you have some desired result. Now you want to obtain that from the left-hand side. Here, mere simplification doesn't give you the solution. Why? Here, in this side, all angles are equal to A. In the right-hand side, what you have is 2A. So you need to, if you want to obtain this, we don't have a formula for cosec 2A. But we have formulas for sine 2A and cosine 2A, sometimes, yeah, of course, tan 2A. Now you can write cosec 2A as 1 over sine 2A, but you have 2 up there. So you need to obtain sine 2A. So cross your fingers and see what you can do. So tan A is sine over cosine. The only thing you can do is to express everything in terms of sine and cosine. If you don't have any idea what to do with that, because cosine and sine have connections with all those trig functions. So because of that, we do it like that. Now take the common denominator. Luckily, you get sine squared plus cosine squared, which is 1. Now you need to prove this sine 2A. Sine 2A is 2 sine A cosine A. So you need an extra 2 there. So multiply both upstairs and downstairs by 2. So you will get 2 sine A. Upstairs you get 2. Now using the definition of the reciprocal function, you can write this as cosec 2A. So that's it. Here, tan squared minus sine squared is this. Next time I don't want to do it like that. Next time I'll work them out. But, since I have already written this, I thought it would be easier for you to understand it like that. This problem is not very difficult, right? At this point. But when I gave you this problem sheet or the paper, probably you had a little exposure at that time, but it's different now. Now you take this. You want to write it in terms of sine and cosine, sine and A, right, you have to show that it is equal to sine A tan A. Again, we have no idea what to do with that. And there's a square root. So you have to get rid of the square root, okay? Now the only thing is that you can express this in terms of sine and cosine, because that's the only hope we have, right? Otherwise, how can you connect sine or tan? There's no way to do that. Now write it like that. And since you need sine A, you can see that there's a common factor. Pull out sine squared. So it will leave you with 1 over cosine squared minus 1. Now leave it like that. Now you can simplify. Look, 1 minus cosine squared is sine. And at the same time, since you need sine A, you pull this out. When you pull out a square, you will get a square root. So sine A times this. Now this is sine A over cosine A, quantity squared. Now that is tan A. So tan A is in the square root means, tan squared in the square root is equal to tan A, which is in fact the right-hand side. Here I have probably skipped one step, but that's okay. This is tan A quantity squared. So when you take the square root, you get tan A. Here, this is little trickier, compared to the other three, but it is in fact not difficult. Now you need to show that it is equal to sec 2A. Tan A sec 2A. Now there's a big problem here. You have two angles here. Here also you have two angles. Therefore, the best thing you can do is that we just obtained the formula for tan 2A in the previous section. So you know what it is. Just if you write tan 2A, you get 2 tan A over this. You can see that you can pull out the tan A. So that will give you this tan A, right? So you pull out tan A. So you will end up with this, right? 2 over 1 minus tan squared minus 1. Now, after that, you have no idea what to do with that. If you want, you can write sine over cosine. Still, we have no idea. So we'll just take the common denominator and simplify. So you get 2, this minus 1 times this. Again, we can simplify. 2 minus 1 is 1, minus times minus plus tan squared A. Now, after that, again, we have no clue because this is what we need. We already obtained tan A, and we have to show that this is equal to sec 2A, and this is sec squared. But don't write sec squared, you will lose you away. You will lose you away if you do that. This is sec squared A, but don't write this sec squared A, but don't try to, replace it by sec squared A. Instead, this is what you need to do. We'll go from the other side. I mean, this is what you need. This is the line of thinking you need. Now, sec 2A is 1 over cosine 2A. Now it's clear. We need to write this in terms of cos 2A. So that means once you are in this stage, there's no hope. With tan, we don't know what to do with sec 2A. Therefore, write everything in terms of sine and cosine. This is sine squared over cosine squared. This is also sine squared over cosine squared. Now multiply each, and once you have this, like in the in the instance that we obtained tan 3A. Can you remember? We did something like that. When it is too complicated, we multiplied like here. We multiplied each and every term by 1 minus tan squared theta. So do the same thing here. Here you have cosine squared. So multiply each and every term by cosine squared. So this will become cosine squared, that is sine squared, like this. And then you have cosine squared minus sine squared. Look, this is 1. This is the standard formula for cosine 2A. There are in fact three other formulas, two other formulas, but cosine squared minus sine squared is cos 2A. It will give you, you don't have to write it again. I just wrote that just to show you how you think about the line of, how you figure out the line of thinking. Now this is sec 2A, and that's the right-hand side, and that is the answer. So three parts are like that. Now we'll do the other parts of the paper. The first problem is very similar to a past paper question, like like a examination type question. But these two are not. Part B is yes. This problem is very similar to, not the exact problem, but we had a similar problem in 2013, I guess, or 12, something similar to this. Right? However, the last part, the problem we just discussed, is not a examination type question. That's a practice question, right? Okay. All right, we'll now discuss problem 1 and the part A of problem 2. Okay. We'll start with problem 1, part A. Here, this is on quadratic equations. Part B is on remainder theorem. Now, in A-level paper, you get a similar question in problem 11, right? Okay, in this case, a quadratic equation is given and there are some data. So some details on B and C are also given. It says that B, C are real and 1 minus B plus C is not equal to 0. Those are given for some purpose. Now look, there are basically 4 parts in this question. First is that we need to show, right? The first part, we need to show that 1 is not a root of this equation. Thereafter, we have to obtain alpha plus beta and alpha beta. After that, we need to, in fact, 5 parts. We have to show that alpha minus 1 times beta minus 1 is equal to something. Then we have to obtain a certain quadratic equation, and there are altogether 5 parts in this part A. Okay, now first we need to show that 1 is not a root of this equation. We have gone through this when we did, when this is covered a little time back, like nearly 4 months back. What we use is that we have to come up with the contradiction, right? To do that, you assume the false statement, or say you need to show that 1 is not a root. You assume that 1 is a root, right? One be a root. Then it should satisfy this value should satisfy the equation. So 1 squared minus b times 1 plus c is equal to 0. That will give you 1 minus b plus c. However, in the assumption, it's given that 1 minus b plus c is not equal to 0. Since 1 minus b plus c is not equal to 0, this is a contradiction. That word should be important. Therefore, our assumption is wrong. Therefore, 1 is not a root of this equation. After that, we need to find alpha beta and alpha plus beta. Let the roots of this equation be alpha and beta. So alpha plus beta is minus of this divided by 1, which is b. Alpha beta is c over 1, which is c. Now, since we have both of them, both are at our disposal, let's find this alpha minus 1 times beta minus 1. This question is in fact very similar to the question we had in 2016. Not exactly the same, but kind of there's some similarity. Now we'll multiply alpha beta. So this is not a difficult, this is not an easy problem. So you might find it easier, but This is not an easy problem or just a cakewalk or a practice question. Now you just expand it like that. Now pull out a negative sign from these two. You get alpha plus beta in the bracket. Now you can substitute these values. Yeah. So alpha beta is C, alpha plus beta is B plus 1. So this is what you get. Right? Now we need to find the quadratic equation with roots 1 over alpha minus 1 and 1 over beta minus 1. Right? The equation with roots 1 over alpha minus 1 and 1 over beta minus 1 is this. You start with x squared, then sum of the roots times x plus 1 over alpha minus 1 times, this is simply the product of the roots. Now, don't try to rush through. Don't try to, now we have a formula for this, expression for this, but don't try to substitute this. Don't try to rush through, right? Okay, these are some our solutions. Try to get the common denominator here. The common denominator is alpha minus 1 times beta minus 1. Upstairs will be one, like by crisscross multiplication, you can get that. So 1 times beta minus 1 and 1 times alpha minus 1. You will end up with this. Just leave it like that. Don't try to expand. Because this is a familiar form for us. We have just obtained the formula for that. Now multiply each and every term by this. Alpha minus 1 times beta minus 1. So you get this. When you multiply this by alpha minus 1 times beta minus 1, you will get this. So alpha plus beta minus 2. When you multiply it by this, you get 1. Now we have a formula for this. It is C minus B plus 1. This is B. So if you compare the form that you need to prove, there you have a positive sign. So pull out another minus sign from this. So this will be 2, this will be minus B. Now we need to prove another thing. If alpha is less than 1 and less than beta, you need to show that like 1 plus C is less than B or something. You prove something like that. So with this, there are two inequality signs. So you can come up with two independent inequalities like this. Alpha is less than 1 and O is wrong. Huh? Both should satisfy. Now, since we have a formula for alpha minus 1, you come up with an inequality for alpha minus 1. You bring this 1 to the left-hand side. And in the same fashion, you take this 1 to the other side. So you have this. Now, one is negative and the other is positive. That means if you multiply these two, one is negative, the other is positive, means product is negative. Now you have a formula for this. It is C minus B plus 1. C minus B plus 1 less than 0. Bring that B to the other side. That's what you have. You need to show. So that part is over. But out of the quadratic equation, problems we got from quadratic equations, this is a relatively easier problem. But this is like examination paper type question. I think in 24, we got an easier problem than this. 17, I guess. We got something easier than this. And this is also can be classified as an easier as an easier problem. Right? Okay. Now we'll go for part B. Part B is from remainder theorem. Now in that problem we have fx given. Again, this is like a problem we had in 2018 and 2019. But we didn't get the same problem, but we had something similar to this. And it's given that C and D are real numbers. Now, you know what the remainder theorem is, right? When you divide something by x minus a, the remainder is f of a. And on the other hand, if you want to show that a certain factor is, certain expression is a factor, you have to show that the remainder, when you get once a given polynomial is divided by that expression is 0. Because if you take numbers, for example, now we know that 6 is a factor of 24. We call it a factor because when you divide 24 by 6, you get 0 remainder. All right. Now, first we need to show that when fx is divided by x minus c, the remainder will be like 2 plus cd plus d. The weird thing in this problem is that you exactly don't know what the remainder is. And it's on the other hand, you even don't know what the divisor is, right? Like you divide it by, sorry, not the divisor, what the divisor is, x minus c. So c is something we don't know. Therefore, we completely don't know what the divisor is. But that's the beauty of this problem, right? So, by remainder theorem, when you divide something by x minus c, the remainder will be f of c. And the remainder is given in the problem, right? I better list the data given in the problem, then I'll do it. Huh? Otherwise, it might throw you away. These are the data we have. I'll just write the problem, the summary of the problem. But you don't have to write it like that. Huh? When you answer the problem question, you don't have to answer it like that. But for the sake of clarity, I'll write the problem briefly. When fx is divided by x minus c, the remainder is given as 2 plus cd plus d. And we need to find c. This is something, this is the data, this is what we need to find. And then there's another thing given. So we have to show that x minus x plus c is a factor of fx. Then we have to find the remainder when fx is divided by x plus 2c. We have to find that. Then we need to find, there's another thing. When fx is divided by x plus 2, 2c, sorry, the remainder is given minus 2. We have to find d. Then find the remainder when this is divided by x minus 1. So we need to find 3 things, right? All right, this is summary of the problem. This is given, we need to find C. This is given, we need to find D. There are 4 things. We have to show that this is a factor. Now, using by remainder theorem, when it is divided by x minus c, the remainder will be f of c. It is given that the remainder as 2 plus cd plus d. F of c is c cubed plus c times c squared plus CD plus D. Now look, some terms will go away. You get 2 is equal to C cube plus C cube. So 2 is equal to 2C cube. Now divide both sides by 2. Now get the cube root. It's not like the square. If you have the cube root, you can just take C as 1. Just take the cube root of both sides. Cubic root of both sides. However, if you want, you can factor this, but all the other roots will be, if you factor that, all the other roots will be complex, not real. That's why you can do it like that. If you have a cube, you can always do it like that. Now we know what the value of C is. Now this is a factor. Factor. Once you divide it by x plus c, the remainder will be f of minus c, right? If it is a factor, it should be 0. The remainder should be 0, right? So I have to show that. I don't write it as 0, I simplify, I find this. Now f of minus c is, you plug in minus c for x. So this is minus c cube. This is c times c squared. C cube minus dc plus d. These two will be gone. You get minus dc plus d, and c is 1. So minus d plus d. C is 1. So this is 0. F of minus c is 0. Therefore, you have to you can write it like this. You have to show that. I am sorry. By remainder theorem, when it is divided by x plus c, this is the remainder. When you divide it by x plus c, right? This will be the remainder. So it is 0. Therefore, x plus c is a factor because the remainder is 0. Sorry, I have messed it up a little bit. Now, this one. I forgot to write this, it is something that we need to prove. There are 4 things we need to show. Now we have to use this data to find D. Now when you divide it by x plus 2c, the remainder is minus 2. Again, by remainder theorem. When you divide by x plus 2c, the remainder is f of minus 2c. Minus 2c is the value which makes this device 0. Now, remainder is given. It is minus 2. So the remainder is minus 2. Now find f of minus 2c. So x is minus 2c, so it's cube, plus c times minus 2c squared. Now d times minus 2c plus d. Now what you get is that you get 8c cube minus. Why? When you raise minus 1 to its cube, you get minus. 2 cube is 8, c cube is, so c cube is simply c cube. So that's the rules for indices, right? Now this is c times 4c squared. This is minus 2cd plus d. Now c is 1. So this is minus 8 plus 4 because c is 1. This is minus 2d plus d. So this minus 2d plus d is minus d. When you bring that to this side, it is d. You have minus 8 plus 4 plus 2. D is minus 2. Now we know what C and D are. Now you can find the remainder when it is divided by x squared minus 1. You can either use the division algorithm and take remained as ax plus b, or you can use long division. When you use long division, you have to be a little bit careful. First, figure out fx. Now, c is 1, d is minus 2. So that is fx. Now, divide this by x squared minus 1. Now, you have to be extra cautious in this case. Huh? Right. Now, when you divide it by, okay, when you perform the long division, you divide the leading terms. X cubed should be divided by x squared. You get x. Right. Now, when this is divided by x squared, you get x. Now, when you multiply, you get x cubed minus x. Wrong. That's a bad thing that you, right? You cannot do it like that. Always look here, one term is missing, x is missing. You have the second order, like second power. First power is missing, x is missing. Therefore, when you write the corresponding terms, you have to align the similar terms. You have to, that's why I told you, you have to be extra cautious when you perform long division, when one term is missing in between. So when you multiply this by x, you get x cubed. X times minus 1 is minus 6, and you need to write it here. Now subtract. This is 0. This is x squared. Minus 2x, now it is like this. Huh? Minus 2x minus 6. So these two will make it positive. So it is minus x. Minus 2. Bring that down. Now this is what you have. Now divide x squared by x squared. You get 1. Now multiply this by 1. You get x squared. 1 times minus 1 is minus 1. Write it here, just below the constant. Now subtract. 0. This is minus 6. In the same fashion, this is minus 1. Because minus 2 minus minus 1. So minus 2 plus 1, which is minus 2. So this is the remainder. Now we have to do two more parts. One inequality and one partial fraction. Right. So part A, part 1, there are two parts. We have to obtain, we have to solve this inequality. So this is what we need to do. When you have an inequality, you have to bring all the variables to one side. After that, you take this as fx. Let fx be this. Because we like to have a little discussion, so that I'll name it like fx. Now you find the critical values. Like this is a rational function. You have upstairs and downstairs. You find the values at which values of x at which fx becomes 0. And on the other hand, you find the values of x at which fx is not defined. Now, when x is equal to 2, fx is 0. When x is equal to 0 or minus 4, right? 0 makes this guy 0, minus 4 makes the other factor 0. Fx is not defined. Now, there are three critical values. Now, this is what you need to do. This is a number line. Sorry. Mark those 3 points. I mean, you can sometimes prepare a table, but that's a long process. You don't have to do it like that. So minus 4 is there, then 0, finally 2. Minus 4, 0, sorry, 2. It is the number line, so you have to write it in the correct order. Now find the sign in each interval. These 3 points divide the entire number line into 4. Right. Now, this is what you have to do. Go for the sign of fx at the rightmost interval. That would be easier for us. In the rightmost interval, you know, a lot of factors are, tend to be positive. Now, if x is very large, say 10, for example, you choose some value in that range. So 10 minus 2, it is positive. 10 is positive. 10 plus 4 is 14. The square is clearly positive. So the entire thing is positive here. After that, you have to cross this over. When you cross this over, the sign of this is changed. Or you can choose some value in between, like you can choose 1 or something and find the sign, but it's time taking. The easier way to handle an inequality like this is to, uh, you know, uh, take this 2, look at the factor which generates 2. It is this, right? This is a simple factor. Therefore, its sign is changed. This becomes negative. After that, when you cross this over, x is there, 0 is there because of this factor. If it's a simple factor, it changes the sign. Or if it's an odd-powered factor, sign is changed. Even with the even-powered factors, sign is not changed. Why? Because even-powered factors change the sign even times. Say 2 times, for example, say plus 2 minus, minus 2 plus. Again, the sign remains the same. So here, 4. If you take minus 4 is there because of this factor. Now it's a square. So the sign doesn't change. And we have to choose the values of x at which fx is negative or 0. Negative or 0, less than or equal to 0. Now it is negative in this interval and it is 0 at 2. Right. Now that is the answer. Now you can express the answer in several different ways. Like you can say x is between this, including 2, or you can write it like this, write it as an interval where 2 is inclusive. Therefore, you have to come up with the square bracket this way or this way, either way. You can express the answer. Now, part 2. There's a partial fraction expansion. You have to find the partial fraction form of this. You know, you look at the partial fraction form using the downstairs. Since you have an x, you have to write a over x. Since you have x plus 2 quantity squared, right? You have to do it like this. B over x plus 2. You have to start from the lowest power until you hit the largest power. So that's it. Now we need to compute a, b, and c. Take the common denominator. X and x plus 2 quantity squared. Don't go for cube. It is not necessary to go for a cube because x plus 2 quantity squared includes this. Or this is included in x plus 2 quantity squared. So when you take the common denominator, you don't have to include that. I mean, you don't have to include all 3. I mean, if you just take this, x plus 2 is included there. Now get the common, get the upstairs. Earlier x was there, still it is there. So multiply a by x plus 2 quantity squared. When you go for b, x plus 2 is there. So you have to multiply it by x and another x plus 2. And when it comes to this, you have to multiply upstairs by c. Now, since the downstairs are equal, you have to make the upstairs equal to each other. Plus b times x plus 2 plus cx. Right? Now, you expand this. So x plus 2 quantity squared is x squared plus 2ab term is 4x plus 4. This is bx squared plus 2bx plus cx. Now you can gather similar terms. Two terms carry x squared, so a plus b. There are three terms carrying x. This is 4a. There's another term carrying x, 2b plus c. Now there's only one term which is a constant, which is 4a. In this side you have x minus 4. Now by comparing coefficients, you can figure out these constants. Now this side you have 4a is equal to minus 4. So a is minus 1. If you compare the coefficients, sorry, don't go for x. You have all three unknowns there. Go for x squared. Then there's no x squared term here. The coefficient of x squared is a plus b. A is minus 1. So b is 1. Right? Now go for this and come up with, equate the coefficients of x. In this side, it is 1. This is 4a plus 2b plus c. A is minus 1. B is 1 plus c. So if you bring this down, 1 plus 4 minus 2 is c. C is 3. Now plug in those values here for a, b, and c and obtain the partial, find the partial fraction expansion of this guy. A is minus 1. So it is minus 1 over x. B is 1. So it is 1 over x plus 2. And c is 3. So that's the partial fraction expansion. So from this time onwards, this week onwards, every week, we'll do some examples like that. We don't have to do unnecessarily difficult problems because that might lose your confidence, because there are two things that we shouldn't do something like that. Right? Because if you try to do very difficult problems, it is like beating the air. Like, there's no point of doing extremely difficult problems. There are extremely difficult problems, but if you do that, you might think, okay, I am not in a position to do these problems. I don't have potential and stuff like that. In fact, in the examination paper, you don't get difficult questions, right? You get easy and moderate questions. Therefore, but we have to do some difficult problems once in a while. But if you try to do very difficult problems, you might lose the confidence and finally end up with nothing. Right? We have to do easy and moderate questions. If you do that, you can go for very good results. That's the trick. Like, say, for example, if you want to be a weightlifter, do you start with 100 kilos in the very first day? No. You have to start with the very low weights, and then gradually you can go up to higher levels, right? So that's exactly what we need to do. Otherwise, I am destroying you if I try to do very difficult problems right from the beginning. If you expect something from me, or if you think that somebody who does very difficult problems is a great guy, no, they are destroying the students. That's the main reason that even though we do moderate and easy questions, more moderate and easy questions, and we do few difficult questions, we have the best results in the city. And we have a lot of district firsts and one island top, and but that island top is from Colombo, not from Kandy. And there are almost every student who enter the university does really well, because they do really well. Most of them, almost all the time, they are batch tops. not that everybody is going to be the best of, but if somebody in our class go to some batch, that person most probably become the best of, like that. Huh? So usually, I mean, we have to target, like, we should have a longer target, like, rather than just getting through the A levels. Now you have to perform well in the university, you have to perform well in the industry, or you have to perform well in the academics. I mean, we don't know what we are going to choose after A levels and after the degree. But no matter what your choice is, you have to perform well. So I have to groom you in a certain way so that you would perform well in future. It is not like to crush you. Like if I try to do very difficult problems, I'm actually crushing you. You don't see that, you don't feel that, but actually that's what I do if I do it like that, right? But I have to do once in a while, I have to do difficult problems. So next time it will be a little more difficult. I mean, there are some easier questions here. Like, for example, problem 2 part C is relatively easier. So next time you don't get those type of questions. Problem 1 is fair. It's a fair question. Problem 1 is all right. And the partial fraction expansion as well as the inequality, I mean, those are simpler. So next time you get something more difficult. I am not going to include vectors next time. Probably we can wait for some time to do those problems, like 2 weeks. Because in the single medium, I am doing coplanar forces. After that, I have to do the difficult problems, so the examination problems from vectors. At the same time, for the English medium class, I can finish vectors. And we have to do more inequalities consisting of modulus functions. We have to do that as well. All right. So I'll see you tomorrow, right? And tomorrow I'll give you another paper similar to this. All right. So I see you tomorrow. And discussion will be most probably on next Tuesday. Okay. Thanks.